All right, so let's see this particular question now. Find largest word in a dictionary, right? So in this particular problem, we are given a string S and a dictionary D of words, right? So this is my string S, right? And this is a dictionary of words, right? So basically it will be an array and it will be having multiple strings in it, multiple words in it, right? That is what we are calling as a dictionary. And now what we need to do is we need to find the longest word in D, that is this dictionary, that can actually be formed by deleting some of the characters of S, right? So for example, if you consider this particular word in the dictionary, the first word ALE, then essentially this particular word, all the characters of this particular word should be present in this string and they should follow the same sequence as is present in the original word, right? So for example, if you see A comes first, then I have L here as well, and then I have E, and I have E here as well, right? So that means I can actually just delete the rest of the words from in between and from the end, and then I will be left with ALE, and hence I will be able to form this particular word of the dictionary from this particular string by deleting some of the characters of this particular string, right? So that's essentially what we have to check, that all the characters of this particular string appear in this particular string in sequence, right? There might be other characters as well before and in between, right, of these characters that we are matching. But then if they are appearing in sequence, we can actually form this particular word of the dictionary using this string S by deleting some characters, right? So that's what we have to do. And then now we have to find the longest such word from this dictionary, right? So ALE can be one candidate, right? It's a valid string which can be formed by this particular string S. Again, apple can also be another string which can be formed by this particular string. For example, if you see A, P, P, L, and E, all the characters of the word apple come in sequence in this particular string, and hence apple can also be formed using this string S, right? And if you see apple is actually longer than ALE, so then apple will be my actual output, right? And not ALE. And if you see even PLEA, plea, can also be formed using this string S, but then the longest string, if you see, that can be formed from this particular dictionary of words is actually apple, and hence my output will be apple, right? So this is what I need to do in this particular question. Now maybe you can just pause this video and try to think of a solution, and once you are done, you can just come back and check the solution. Okay, so now to solve this particular question, see, as we already discussed, what we need to do is we essentially have to check for every word in this particular dictionary that if every character in the individual word actually appears in this particular string in the same sequence or not, right? So to do that, to check that, what we can do is we can have two pointers. One pointer will be actually pointing to the first character of the string S, right? And the second pointer will actually be pointing to the current word in the dictionary, right? So we will be looping over all the words over this dictionary, and whatever is the current word, right, wherever we are at currently, we will be iterating over all the characters of that particular word, right? So my second pointer will essentially be pointing to the start of the current word that we are at in this particular dictionary, right? So to start with, my first word would be over here, ALE, and I would be pointing to the first character of this ALE, which is A, right? And my first pointer would be at the first character of string S, right? That's what I would be doing. Now what I will do is I will try to match if the current character of my current word in the dictionary is actually equal to the current character that I'm pointing to in my string S, right? If they are equal, then what I will do is I will just move to the next character, right? Because I was able to match the first character, the previous character, and hence I'm moving to the next character now. And now I will try to match this L, right? The second character. And in this particular string, anyway, I will just keep moving towards the right, right? Without any condition, I will just keep looping over. And now in the second iteration, I will be at B. I will check if B is equal to L or not. They are not equal. So I will just move to the third character, right? And I will just keep my pointer to L only because till now I haven't been able to match L, right? So I'm still trying to uh, identify if I have L in this particular string or not, right? So I will be at L only. I won't be moving towards to the next character over here, but I will be moving to the next character in string S. Again, I will try to match P with L now. Again, they don't match, so I will just move to the next character and stay over here only in the current word of the dictionary, right? And then I get, I think C, I was at P, I think I get C. Again, C is not equal to L. So then again, I will move to the next character. Now I get P, again, P is not equal to L. So again, I will move to the next character. And now L is equal to L, right? So over here also, I will move to the next character. And over here also, I will move to the next character, right? Because I was able to already match this one. So now I have to check for the next character if it is present or not, right? And we will just keep doing this. We will just keep moving in the string S and try to one by one keep matching all the characters that we are encountering in the current word of the dictionary. And in that way, we will ensure that whatever matches we have encountered are actually in the right sequence, right? So that's the algorithm. That's what we will do for every word of this particular dictionary. First, we will do for this, then this, then this, and then this, right? That's what we will be doing. And, as and when we are finding a valid string, which basically becomes a candidate, to be formed using this particular string as after deleting some characters, if we are able to find, such string, we will keep maintaining the longest such word that we have encountered so far, right? So we will just maintain a longest word variable and we will just initialize it to an empty string to begin with, right? And as in when we are encountering new strings which qualify to be formed using string S, we will just keep comparing the current length of the longest word that we have encountered so far with the current word, right? The current word itself. And if the current word's length is actually greater than the current word which is present in the longest word, I will just reassign the current word of the dictionary to my longest word, right? And in the end, after I have iterated over all the words of this particular dictionary and I have checked for all these words, I will be able to just return that longest word as my output, and that will always contain the longest valid word which can be formed using the characters of the string S after deleting some words, after deleting some characters, right? So this is the algorithm entirely. I hope you understood it well. Now also let's try to backtrace this particular same example using this particular algorithm, and that way it will be more clear. So if you see over here, now we are trying to match ALE, right? And if you see over here, we were able to match A over here, and then we just kept moving until we got L, and then we were able to match L, then we moved to E, and then we again were able to match E at the very next character. And the moment we matched all the characters of this current word, we will break out of the loop because we have exhausted all the characters of this current word, right? And if we are actually exhausting all the characters of the current word of the dictionary before we exhaust all the characters of this string S, that means that we were able to fully match, all the characters of this particular current word in this string S in the right sequence, right? So that's why we will just break after we matched E. And now since the current max initially would be having an empty string, my current max will get reassigned to this ALE, right? Now we will move to the next word, which is basically apple. And now I will just keep moving from the left to the right in my string S, and I will just keep matching if my current character in string S is actually equal to the character that I'm currently pointing at in my dictionary word, right? In the current word of the dictionary. So for example, I was able to match A and A, so I moved to B and I also moved to P over here. Then I was not able to match B and P, so I just moved to P over here and I was still at P. Then I was able to match P, right? So I moved to the second P over here and I also moved to C over here. Then again, I was not able to match C and P. So I just moved to the next character over here and stayed over here. Now I was able to match P. So then I moved to the next characters in both these strings, right? To L over here and to L over here. Again, I was able to match L and I was able to match E, right? And now this is a valid string. Now I will compare the length of this particular string with the current max that I already have, which is ALE, right? Before I got apple, I got ALE, and the length of apple is actually greater than ALE. So I will just reassign current max to apple, right? So that's what I'm doing over here. And then I will go to the next string. Again, I will just try to uh, form monkey out of the string. I won't be able to match any character. So I will just move to the next string. I don't have to do anything. Now I will try to match PLEA, right? All the characters of it. I'm able to do so. So that means this is also a valid string. But since PLEA, the length of it is actually lesser than apple, I won't be doing the reassignment. The current max will stay to apple only, right? And finally, once I've exhausted all the words in the dictionary, I will just come out of the loop and I will just return my current max, right? Which will be my final result, right? So this is the entire solution. I hope you understood it well, right? And now see, talking about the time and the space complexities over here, the time complexity over here is that we are actually looping over all the words in the dictionary, right? One by one. And then we are actually looping over all the characters of that individual word, each of that word in the dictionary, right? So for example, if we have n words in the dictionary, right? N overall words in the dictionary, and the average length of each of the word is actually, for example, k, then my time complexity will be basically order of n into k, right? Because I would be doing n iterations over each word of the dictionary, right? And in each iteration, in an average case, I would be iterating over k characters, right? So that means I would be having order of n into k steps, and that's why my time complexity will be order of n into k, right? And talking about the space complexity, see again clearly we are not using any extra space over here. So the space complexity will be constant. It will be order of 1, right? So that's about it. The time complexity is order of n into k, where n is the size of the dictionary or the number of words in the dictionary, and k is the average number of characters in each word of that dictionary, right? So it will be order of n into k, and space complexity will be order of 1, right? So that's it for the solution. Now let's see the code for it. All right, so now let's code the solution that we just discussed. So to start with, let me just declare a function over here, find longest string or longest word maybe, right? And this will accept 3 parameters. One will be the length of the dictionary, right? The number of words basically in the dictionary. One will be the string, the input string, right? S, and then one will be the dictionary itself, which will be basically an array of strings, right? So that will be D. Now what I can do is I can just take the value whatever I got in OB in a variable n, right? So that it's more readable. I mean, there is no other purpose, right? And then what I can do is I can also capture the length of the string, the input string, in a variable ns, right? So I can do this. And now what I can do is I can just declare my current max variable, right? Which at any point in time will hold the longest valid word that we have seen so far. And to begin with, we will just initialize it to an empty string, right? Now what we need to do is, now we need to loop through all the words inside this dictionary D, right? So for that, we will have a for loop, and I will say for W, that is word in D, what we need to do is that we now need to iterate through each character of the current word W, right? And then we have to try to match that particular character with, the characters inside of my string S, right? So what I will do is I will just initialize a J pointer, and this will be actually the pointer which will be pointing to the current character of my current word W at any point in time, right? And whenever I am able to match this particular current character at J with any of the character in my string S, then I will be just incrementing this J pointer and be moving to the next one, right? So that's what I will be using this J pointer for. And now what I need to do is I need to loop through all the characters of my string S, right? The input string S. So for that I will do for I in range ns, right? And now I will just check if the current character of my word, that is denoted by W of J, is actually equal to the current character of my string S, which is S of I, right? If this is the case, then I will simply move to the next character and I will just increment my J pointer by 1, right? So this is what I will be doing. And also I will be checking after doing this increment in every iteration that at any point in time, if my J, like the J pointer, becomes greater than or equal to the length of the current word, right? And what are we trying to check through this condition? Through this condition, we are trying to make a check that if I have already exhausted all the characters of my current word or not, right? Because if the J would be actually equal to or greater than the length of the word, that would mean we have already hit the end of the word and we have already matched all the characters of the current word with some or the other character at some or the other index in my string S, right? And hence the current word W would be a valid word, right? And now since it is a valid word, what we need to do is we now need to compare it with the existing value of the current max, right? If the length of the current max is actually lesser than equal to the length of the current word, then I can actually reassign my current max to this current word, right? And also, like, since it was given in the question, you must have seen that in case, we are encountering two valid strings of equal length, we have to actually consider the smaller of those strings in the lexicographical order, right? So in case the length is actually equal of the current word and the existing word in the current max, then we will be considering the lexicographically smaller string, right? So for that, we will be just writing few conditions over here, that if my length of the current string, right, which is the current max, is actually equal to the length of the current word, right, like this, then what I would be doing is I would be actually reinitializing my current max variable to the lexicographically smaller string, right? So I will be reassigning it to current max if in case my current max is actually lesser than x. I'm sorry, lesser than w, not x, right? Why am I writing x, right? Right? Else I would be assigning w to it, right? So whichever is the lexicographically smaller string, I would be assigning that particular word to my current max, right? In case the length of the current max and the current word are equal, right? But if they are not equal, if they are different, then my job is simple. What I just need to do is, in that case, I just need to assign the greater length word to my current max, right? And so for that, I will be just doing this assignment like this. I will be assigning current max to my current max if in case the length of my current max is actually greater than the length of my current word that I'm at right now, right? Else I would be assigning the current word to it, right? So whichever is greater in terms of the length, I would be assigning that to my current max. And in case both of them are equal in length, the current max and the current word, then I would be assigning the smaller of the two strings in the lexicographical manner, right? So that's what we have to do, right? And once we are inside this particular condition, it would mean that we have exhausted all the elements of the, or all the characters of the current word, right? So in that case, we can just break out of this inner loop, right? Because see, we are actually looping over all the characters of string s, right, in my inner loop. So there might be, even after exhausting all the elements of my, or all the characters of my current word, there might be still some remaining elements in my string s, right? And unnecessarily I would be just looping over them one by one, right? So to prevent that, once I hit this particular condition that my j pointer becomes greater than or equal to the length of the word, I will just reassign my current max variable, right? And then I will break out of the inner loop and go to the next word, right? So that's why I will just break off my inner loop then, right? And once I have finished looping over all the words of my dictionary, then I would be having at the end the greatest valid word from this particular dictionary, which can be formed using the string s by deleting some elements from this particular string s in this particular current max variable. I would be having longest such word present over here in the current max variable, right? So after coming out of the loop, the outer loop, I mean, we can simply return the current max variable, right? And that would be my final output, right? So this is the entire solution to this particular problem. I hope you understood it well, right? And time complexity, as we have already discussed, it will be order of n into k, where n is the number of words in the dictionary and k is the average number of characters in each of the word in this particular dictionary, right? So it will be order of nk, n into k, and the space complexity will be constant. It will be order of 1, right? As we have not used any extra space over here. So that's it for this particular problem. And now I will see you in the next one. Thank you.